Okay, this will be the first homework review video of the semester, covering the review chapter assignment that was just due. So I'll be posting one of these videos every week. Just as a warning, for most of these videos I'll be just reusing videos from last year, since things don't typically change very much year to year. But for this one, this will be a new video because this assignment was not previously a graded assignment, so only very recently did we make this assignment count towards your grade. So because of that, I want to make sure that I go over. So what I did is I went through Blackboard and I identified the problems that we had the most difficulty with. The ones that I chose for this video, we all had success rates of 50% or less. I think they're all good ones to go over. So we'll jump right into it. The average score on this assignment was pretty good. I think it was around 10.4 for the score that counts in Blackboard. So that was, I think, fine. Again, we didn't grade this assignment before, so I don't have a lot of comparison for that number. But it's important that we have good foundation on this stuff because it's stuff that I don't directly teach you, and even though a lot of it doesn't seem particularly relevant to chemistry, the math operations, the significant figures that are part of this are going to be important for a lot of the things that we do in this course. All right, so let's get right into the first question. So we had questions on this assignment that just asked us to, add, subtract, multiply, divide numbers, and report them to the correct number of significant digits. So there's sort of two rules to consider, and I guess I'll briefly summarize them here. So for multiplication or division, when you multiply or divide numbers, and we want to come up with the correct number of significant figures. And it turns out in chemistry, at least for the stuff that we do in chemistry 1, multiplication and division is the much more common thing that we'll be doing mathematically. So when you multiply and divide numbers, the answer has the same number of significant figures, or significant digits as they're sometimes called, as the number you're multiplying or dividing that has the least. So it's kind of a mouthful, but all right. So for example, without even going into the numerical, designation, if you were to multiply 1.2, trying to do this all the time in my head, 1.23 times 3.2, and then dividing that by 4.567, just to give some real. Okay, so what we're doing is we're multiplying two numbers and dividing. This first number has 3 significant figures, the second number has 2, the one we're dividing by has 4, so this one has the fewest number of significant figures, which means our answer should have only 2 significant figures. So 1.23 times 3.2 divided by 4.567. The calculator spits out 0.86183449 and so on, but we only want to have 2 significant figures in the answer, so we would round it to just 2 digits. And in this case, it's a decimal number, so both digits after the decimal are significant. So that's just a random example of how I multiply and divide. It didn't seem like we had particular trouble with that. But for this problem, we're doing addition. We're adding 3 numbers together. So for addition and subtraction, you could write the rule pretty much the same as above, but it's determined not by the number of significant figures, but by decimal places, which would be any number after the decimal, including zeros. And so when we're adding and subtracting numbers, we don't have to count the total number of significant figures in the numbers that we're adding or subtracting. We have to count how many decimal places they are. For this one here, the numbers are written in scientific notation, so it's not particularly easy unless you're, a wizard at scientific notation to really figure out how many numbers after the decimal places these three numbers have. And so what we would want to do in this problem, we can put it in our calculator, and most calculators allow you to convert between decimal and scientific notation. So, that's something you should definitely learn how to do with whatever calculator you're going to use. But it is going to be helpful in any case to write these out in decimal form. So this first one, 7.4576 times 10 to the minus second, in decimal form will be written as 0.07457 We're going to add that to 0.411 times 10 to the minus fifth. So how would we write that in decimal form? Let me make sure I get this right. It's going to be, sorry, give me a second, make sure I don't mess this up. This one should be 0.1234411. Let me double check to make sure I didn't mess up the number of zeros. So it'll be 4 zeros before the decimal in that case. Yeah, okay. And then the last one, which is 6 times 10 to the minus 4 in decimal form, will be written as 0.1236. Okay, so those are how the numbers will be written in decimal format. And so the number of decimals is going to be 1, 2, 3, 4, 5, 6 for this one, 6 numbers after the decimal point. For this one, 1, 2, 3, 4, 5, 6, 7 numbers after the decimal point. And then for this one, 1, 2, 3, 4 after the decimal point. So when we add these three numbers together, the number of decimal points in our answer should be the same as that which has the least. So our answer should have 4 decimal points. So when we punch all these numbers into our calculator, so let's see what we get. What we come up with without any rounding is 0.07521171. But we want to round this to 4 decimal places. So 1, 2, 3, 4. This should be our last decimal place. The number after it is a 1, so we round down. And so we would write this correctly as 0.0752 with 4 decimal places. And then if we're writing that in scientific notation, which I think is how the answers are presented in the multiple choice, it should be 7.52 times 10 to the minus 2. Okay, so that's the correct number of digits for this answer. 4 decimal places in this case because we're adding, and then that will be written in scientific notation in that format. Okay, so that's going to be the first one, just adding numbers together. We also had unit conversion questions on this assignment. And so it's possible that some of the issues with some of these problems, whether they're unit conversion or anything else, was putting numbers in exponential format. In a lot of the test questions, homework questions we'll have later on, we don't have as much peculiarity or specificity about answer format, but always follow the directions in Blackboard to be safe. And part of the point of this homework assignment was to make sure that you knew how to correctly enter answers into Blackboard. If it's something you're not as experienced with, it just takes some time to get used to. So this one is a pretty straightforward question, but it wants us to use the exponential format, so we have to make sure we can do that correctly. So we're going to convert 4.7 meters to millimeters. So lowercase m, is 10 to the minus third. And so what that means, I'll write it out. So milli means 10 to the minus third. That's what the lowercase m means. So there's 2 ways of then writing the sort of conversion factor we're going to use. 1 millimeter is 10 to the minus 3 meters. So milli means 10 to the minus 3. So we put a 10 to the minus 3 in front of meters. Or you could write, and this is the form that I prefer just to avoid negative exponents, but it's totally up to you, 10 to the third millimeters is 1 meter. So those are the 2 different ways of writing the relationship between millimeters and meters, and you can use whichever one you're most comfortable with to get this question right. So what we do then to convert is we're looking for millimeters, converting meters to millimeters. So we're starting with 4.47 meters, and then we have to just use the conversion factor that converts millimeters. So we want millimeters on the top, we want meters to divide out, so that's how we're going to arrange the ratio, the conversion factor. And as I said, there's two ways of writing it. The way that I'll typically do it in this class is 10 to the third millimeters per 1 meter. And so what we end up with is 4.47 times 10 to the third millimeters, which in Blackboard will be written as 4.47 E3. Now the other thing it asks for is the correct number of significant figures. Well, when we're doing unit conversions, the conversion factors here have infinite, unlimited significant figures. 1 meter is exactly 10 to the third millimeters. That's a definition. There is no measurement involved with that number. So our starting number here clearly has 3 significant figures, 4.47. All non-zero digits are significant. So that's 3 significant figures. That means the answer should also have 3. All right, we had some problems here dealing with density. So I think there's 2 that I'm going to go over here in this assignment with density. We want to calculate the density of an unknown alloy in grams per centimeter cubed if a cube of the alloy 12.1 centimeters on a side has a mass of 2.58 grams. So density is defined as mass over volume. This is a common physical parameter in chemical substances. We won't deal with it a ton in this class, but it is important. It is something we expect you to know before we even start, so it's not something we'll teach a lot about. We'll see it a little bit throughout the semester. So it's defined as mass divided by volume, and the units that we're asking for, grams per centimeter cubed, kind of gives away what the 2 things are that we need to divide. We need the mass in grams, make sure we're having the right units, and we need the volume in centimeters cubed. So we need these 2 quantities to be able to divide them and get the density. So we can do it in either order. The first one is given to us directly as the mass, but it's in the wrong unit. So we need the mass in grams for this problem. So we have to convert 2.58 kilograms to grams. Kilo means 10 to the third. So if we want to convert into grams and divide out kilograms, that's going to be 10 to the third grams in 1 kilogram. So 2.58 kilograms is 2.58 times 10 to the third grams, or 2,580. Doesn't really matter how we put it in for this problem. So 2.58 times 10 to the third grams, that's our numerator. And that was fairly directly given to us, but we did have to do unit conversion. And then finally, the volume in centimeters cubed. You have to remember from high school geometry that if you have a cube, the volume is just the side length cubed to the third power. And so it's going to be 12.1 centimeters cubed to get the volume of a cube with that dimension. And so when we multiply that out, we get 1,772 for rounding a little bit. Now, in terms of intermediate rounding, this is an intermediate step. Technically, this should have 3 significant figures because we're cubing a number with 3 significant figures, but we don't want to do too much intermediate rounding, so I suggest in intermediate steps either don't round at all, or alternatively, that should be a comma, alternatively, at least keep 1 extra digit like I did here, because the number that it spits out is 1771.561. Kind of a lot of numbers to deal with is an intermediate calculation, but don't round too much in the middle because you might have an answer that's rounded too much and counted wrong for a reason. So we'll use 1772. That should be plenty of precision for this, but we don't want to round it any more than that probably. So we're going to divide those 2. The final answer should be in 3 significant figures because both of the numbers we were starting with are 3 significant figures, but we'll round at the end. So we'll take that and divide those two. And what I got was 1.46 grams per centimeter cubed. Now keep in mind, as I probably didn't directly mention it today, but I should, because part of this is all about Blackboard formatting. You should never try to enter units in Blackboard. I mean, maybe if we specified it in a problem, but typically for any numerical question where you're entering a number, there will never be a unit entered in along with that. So we would just write 1.46 as the correct answer, but we have to look again carefully. It wants it in decimal format, so that's the way we'll write it, is exactly 1.46. No exponents in this case. So just follow the directions in Blackboard and you'll be good. Alright, we have another question that deals with density. So we purchased a water tank with these dimensions. What mass of water does this tank contain? So this actually ends up involving a little bit of an extra step, because here we're going to use density as conversion factor. And so because density is equal to mass over volume, density allows us to convert between mass and volume. It's a ratio of those two. So if we have the mass of a substance, we can calculate its volume if we know the density, or if we have the volume, we can calculate the mass. And that's what we're doing here. So the first thing we need to do is find the volume of this tank. And we're assuming that it's a rectangular tank, so we're not told otherwise. The volume in centimeters cubed. We have to have all three of these numbers in centimeters and then multiply them together. So there's two conversions we have to do. So 2.55 meters times 10 to the second centimeters in 1 meter. That's going to be 2.55 times 10 to the 2. So centi means 100. So 100 centimeters in 1 meter means 10 to the minus 2 technically, but we'll write it in this way. So for the volume, we're going to have 2.55 times 10 to the 2 centimeters for the first number in the correct units. So when we multiply numbers together, they don't always have to be in the same unit, but if we're trying to get a volume in centimeters cubed, then all three need to be in centimeters for that to work. For the second dimension, 2.53 decimeters. Decimeters is not a particularly common unit, but it comes up a little bit in chemistry. And so this one, you probably won't know directly a conversion from decimeters into centimeters, but we can do it in two steps. And so what we would do is there's going to be 10 decimeters in 1 meter. So deci is 10 times smaller than the unit. So 1 meter would have 10 decimeters, or 1 decimeter would be 10 to the minus 1 meters. So that gets us into meters. Sorry, I should do it the other way though, because I screwed that up already. Alright, so anyway, we want decimeters down here, and we want meters up here. So it's going to be 10 decimeters in 1 meter. And then what we're going to do is convert to centimeters. So meters to centimeters, just like we did before. 100 centimeters in 1 meter, 10 to the second. So decimeters cancel out, meters cancel out, and that gets us to centimeters. In that, we're just multiplying the whole thing by 10, so that would be 25.3. So you may know that there's 10 decimeters in 10 centimeters in 1 decimeter. So we'd multiply by 10 to get into centimeters, but that's not necessarily the most common conversion. So here I did it in two steps, just using the definition of deci and centi. All right, so 25.3. And then finally we have the last one is directly given to us in centimeters. So when we get the volume of this, so multiplying those three numbers, we get a pretty big number. So I think the answers here were in kilograms, so we'll get to that in a second. But anyway, we get 1,845,129 cubic centimeters, which is, keep one extra significant figure, as we said, 1.845 times 10 to the 6, I guess. Yep, So that's how many cubic centimeters we have, so a pretty big number. And then from there, we're looking for what mass of water does this tank contain. I think this was a multiple choice question, but I didn't write out the choices, and the answers I think were mostly in kilograms, or at least the correct one was. So let's calculate the mass in kilograms then that this tank contains. So we have 1.845 times 10 to the 6 cubic centimeters for the volume. Now the density of water is 1 gram per cubic centimeter, so we can use that to convert between mass and volume as we said. So we're just multiplying by 1, but it changes the units from cubic centimeters to grams. And that's just the density of water, 1 gram over 1 cubic centimeter. So that's the number of grams, and I think, as I said, the answers are probably in kilograms. So 1 kilogram is 1,000 grams. So we'll divide that by 1,000, and then round to the correct number of significant figures. Would give us 1.85 times 10 to the third kilograms. Alright, so I don't remember off the top of my head what units the answers were in, so I forgot to put the answer choices in here, but if you convert to kilograms, that's what you would get. So for this problem, the key was converting between mass and volume, or volume and mass, using density. So we define the volume first, and then just use the density here as a conversion factor. So that was the key step. And then all else that's left is just unit conversion, which we did many times in this assignment. Alright, the last question I'll go over, it's a little bit early for us to be talking about moles. We're going to deal with moles a lot in chapter, 5, I think. So about halfway through the semester, moles is going to become a very big and very important part of our lives. But here we gave you one dealing with moles. You might say, well, why are we giving us a problem that's so early on, and it's too early for us to do this? In some level, you're right. I will listen to your complaints about that if you have them. But at the same time, what this problem is really dealing with is unit conversion. Now we're defining a quantity that you haven't really seen a lot before if you haven't taken chemistry before. So that might be a little bit unfamiliar. But we're giving you everything you need to solve this problem just by doing factor label method unit conversions. So we want to know the mole is a counting unit defined as 1 mole equals 6.022 times 10 to the 23rd objects. If you have a sample of 3.42 times 10 to the second moles of H2O, how many hydrogen atoms would the sample contain? Okay, so for this problem here, we're going to just set it up as a string of unit conversions. Everything is given to us that we need, as it turns out. We don't have to know anything really to do this problem except how to convert units. So the number of hydrogen atoms is what we're looking for, so I like to write that out first. And then we write what we're starting with. We're starting with 3.42 times 10 to the second moles of water. Moles has a dumb abbreviation, it's just MOL, which is not much different than the word itself. And then from here, we're just going to write out some conversions. So mole is a counting number. It's kind of like dozen. 1 dozen has 12 objects. Well, 1 mole has 6.022 times 10 to the 23rd objects. In this case, the object is water. Water is made up of molecules, H2O, and so 1 mole of water has 6.022 times 10 to the 23rd molecules, is made up of that many objects. So we want moles to cancel out, and then what we can do is use this conversion factor, 6.022 times 10 to the 23rd. That's going to tell us how many molecules of water are in 1 mole. All right, whatever the substance is made of, there's that many units in 1 mole. So water is made up of molecules, so there's 6.022 times 10 to the 23rd molecules in 1 mole. But that's not what the question is asking. The question is asking how many hydrogen atoms would there be. This is total molecules of H2O. And so for that, the step that a lot of students forget, including later on in the course when we start doing this more formally, is look at the formula here, H2O. The formula, we didn't talk a lot about chemical formulas yet, but we should have at least some intuition about them. H2O tells us that each molecule of water has 2 hydrogen atoms and 1 oxygen atom. So the last conversion we have to do comes from the formula of H2O, which is that there are 2 hydrogen atoms in every 1 molecule of H2O. That comes directly from the formula H2O. Alright, so it's that last step that many people probably forgot in this assignment and will continue to forget later on, so just going to keep warning you about that. I hope that all of us get it. before the exam comes up. So when we multiply these numbers out, we get a huge number, and then in scientific notation, let me make sure I think I'm gonna, hang on, let me get this right. 3.42 times 10 to the second times Avogadro's number times 2, and then we're going to divide that by, okay, good. Alright, so three significant figures in this answer. 4.12 times 10 to the 26. Part of the issue with some of these problems, including this one, is especially when you have large exponents like this, you have no choice but to use exponential notation on your calculator. So make sure you know how to do that correctly with whatever calculator you're using. Every calculator has slightly different syntax, especially if it's a different brand of calculator. I'm most familiar with TI, Texas Instruments myself, but there's other common brands that you should know how to use, and I can certainly help you figure it out if you're not sure. So make sure when you look back at your answers on these, that you don't miss problems or didn't get it wrong simply because you're just not quite using the right syntax in your calculator. That certainly is possible as you're getting used to these things. Okay, so that's the answer, and I believe this one would have been entered then as 4.12 E23. I believe this was a problem, or sorry, E26. That's the exponent. It's 26 in this case. I think this was a problem that had variable numbers, so the number of moles of water you could start with could have been a lot of different things. So you probably didn't have these exact numbers in your assignment either. I almost definitely didn't. But whatever number you start with, that's the sequence of steps you would use to convert it. And then again, make sure you're using the correct syntax for your calculator. Alright, so that takes me to the end of this first homework review. Chances are you have other questions that, on your own assignment that I didn't go over here. Can't go over everything, obviously, so please let me know, and please find me with any additional things you want to go over. Alright, thanks for tuning in to this first one. We'll have one of these pretty much every week, and I'll see you guys in class tomorrow.